Hey guys, I feel so happy to meet you all in the next video of Python tutorial series. In this video, we'll be discussing about basic statistics concepts in Python. So let's get started. So before getting into data science, statistics is a mandatory thing to know. So I thought of dedicating a separate video for statistics. So statistics can be defined as science of collection, presentation, analysis and interpretation of numerical data. So statistics is nothing but you will gather some data, analyze it and draw some useful conclusions from the raw data. So this is how statistics works. And the famous American mathematician John Dewey says that statistics is a science and not a branch of mathematics, but uses mathematical models as essential tools. So most of us think that statistics is mathematics, but it is more of a science rather than mathematics. So these are the types of data in statistics. The data can be categorical or numerical. The categorical data is further classified as nominal or ordinal, and numerical data is further classified as interval or ratio. So what is categorical data? Categorical data represents characteristics of a data. So you cannot measure them. It's like categorizing a gender. A gender can be male or female. So this is categorical data. Categorical data is further classified as nominal and ordinal. Nominal data means the order in which you define the data doesn't matter. For example, you can assign 1 for male and 0 for female. So this does not have any quantitative value, but we are simply assigning 1, 0, but it does not have any significance. So this is nominal data. It is just to label variables, nothing else. When it comes to ordinal data, the order in which you represent data that matters. For example, the customer satisfaction ratings can range from 0 to 5, where 5 means customer is highly satisfied and 0 means customer is poorly satisfied. Here the order in which data lies does matter. Let's go to numerical data. Numerical data means as the name suggests, data is numeric. The data can be integer or the data can be fraction. So integer data is called as discrete data and it cannot be in fraction. You can count the discrete data, but continuous data you cannot count it. For example, when I flip the coins 10 times, out of 10 times, how many times I get the heads? This is an example for discrete data. It cannot be in fraction. It's like I will get 5 times of heads out of 10 times flipping of a coin. So it cannot be like 5.5 times I will get heads, right? This is an example for discrete data. Continuous data can be measured. For example, temperature can be represented as 26.3 degrees. So basically all the fractional data is called continuous data. Central tendency of data is very critical in statistics. So also it is very basic thing. In central tendency, we will be measuring a typical value in a data. So when you have a data set and if you want to find what will be a more typical value in that data set, you will definitely using one of these methods. Central tendency can be mean, median or mode. So what is mean? Mean is nothing but the summed value of the data divided by the number of data we have. So here we have x bar is equal to x1 plus x2 till x of n divided by n. Here n is number of data and x1, x2 each represents the data points in the data set. The disadvantage of mean is it is highly affected by outliers. The outliers are nothing but the random values which stand outside the typical value of a data set. For example, let's say we have this data set which represent each staff and their corresponding salary. So if you see, the staffs 9 and 10 are having 90k and 95k, as salaries respectively. But if you take a look at the first 8 staffs, the salaries range from 12k to 18k. So in this data set, the outliers are 90k and 95k, the staff number 9 and 10. If you take a mean, which is sum of all the values divided by 10, is 30.7k for this data. But does it really represent the central tendency of data? I don't think so, because if you see, we are getting 30 because the values 90 and 95k contributed more with respect to mean. So this is a disadvantage when it comes to mean. So to overcome this disadvantage to an extent, we can go for median. Median is nothing but a middle score of data. So first thing to do is you have to sort the data in an ascending value. We are starting from 12k, 14k, and we have 90k, 95k at the end. We have sorted it. It is very less affected by the outliers and skewed data. Here, if the data is even in numbers, for example, we have 10 data points. So we have to take the central 2 data points and take average of it. So 15 plus 16 divided by 2 is 15.5k. This almost represents the central tendency of data. So when I pick this data, I can randomly say a typical value is 15.5k of this data. So let's go to mode. Mode is nothing but most frequent score in a data set. For example, we have each category of sports and their corresponding frequency. So we have number of players, 15 number of players in cricket, only 1 player in football, etc. So the mode of this data is cricket, because I think that more typical value in this data set will be cricket. But again, mode is not very useful when you have similar more number of modes. For example, let's say this data set is having football as 15. So mode is both cricket and football. So it's not really useful, right? So when to use what? When the data is nominal, you should use mode. And when the data is ordinal, you can use median. When the data is interval and it is not skewed, it does not have many outliers, in that case you can use mean. And if the data is very much skewed, you should probably go for median. So in Python, to calculate the central tendency, we have to import these 2 libraries, NumPy and SciPy. So we are importing NumPy as NP, and from the SciPy library we are importing the module stats. So for example, I'm having this data. So if I want to calculate mean for this data, I will be using p.mean. So the mean for this particular data is 36.8. So if you want to calculate median for this data, np.median. So here the median is 13, because when we sort, probably 13 will come to the center, and so the median will be 13. If I sort this, this will become 11, 11, 12 and then 13. So the 13 is the 4th value in a data set which is having 7 data points. That is printed as a median. Another thing is mode. So we can calculate mode using stats, which is the module of SciPy library. This is returning us the mode of 11 and the corresponding count, which is 2. So if I have another 11 here and I calculate mode, the count is becoming 3. So there are 3. So this count is basically representing the frequency of a mode, which is 11. So this is how you calculate central tendency in Python. Another thing is, if I want to measure the variability of the data, the variability is nothing but the measuring how dispersed your data is, how spread your data is. So for that we have a few methods, which are range, variance, and standard deviation. As you can see in the graph, if the data is close towards the mean, it is called as low variability, and if the data is somewhat close to the mean, then it's called as medium variability. If the data is hugely spread, and then it is having the high variability. It gives the first impression of any data set. Let's see how to measure the spread using range. So range is nothing but very simple. It is upper bound minus the lower bound. Here in this data we have the data starting from 7, and it goes all the way to 13. So upper bound is 13 and lower bound is 7. So 13 minus 7, 6. That is nothing but your range. And again, the range is also affected by skewed data. So skewed data is a main enemy in statistics, right? For example, I have given the score and the frequency. So we have data points 8, 9, 10, 11, 12. And if you calculate the range, 12 minus 8, it is 4 for the first data set. And for the second data set, you can see that there is no 9, there is no 11. We have only 1 8 and we have only 1 12. So if you calculate the range, 12 minus 8, it is still 4. But it does not really tells us the spread of a data. If you see the second data set, the most of the values are 10, because the 10 is occurring 8 times. The data is not much spread. It is almost 10 everywhere. This does not tell me the true spread of a data. So this is greatly affected by outliers. To overcome this, we have variance. The variance is nothing but the average distances from the mean squared. This is how you measure the variance. This is the formula. First of all, you have to find the mean of the data. For example, we have the data as 1 4 8 9, and the mean for this data is 5.5, and there are 4 data points. So we have the n value is 4. We have to measure the distance of all the data points from the mean. So 1 minus 5.5 squared plus 4 minus 5.5 squared plus 8 minus 5.5 squared plus 9 minus 5.5 squared, whole divided by the number of data points, which is 4. So I have given it here, and this is how you calculate the variance. You will be getting 10.25 when you do the math. But here is a problem. When you calculate the variance, the result value lies outside the data, right? Here we got the value of 10.25, but actually the data is having only the maximum value of 9. So the problem in variance is you cannot really measure how dispersed your data is from each other. To solve this, we got standard deviation. So standard deviation is nothing but square root of variance. So basically that is the relationship between standard deviation and variance. So we got the variance of 10.25. When we take square root, we got 3.201, which is that standard deviation. So as you can see, 3.201 is the value, is the amount in which the data is dispersed in this data. So let's see how to do range, standard deviation, and variance in Python. So again we have the data. So for this I'm going to calculate the range. Range is nothing but max minus min. So max of data minus min of data. So it is giving us the value of 89 because we have the maximum value of 100, so minimum value of 11. So 100 minus 11 we got 89, but it's not really helping. So this is range, and to calculate variance we use np.var. VAR represents variance data. So variance is 1363 is the variance which we are getting. So that doesn't really represents the dispersion. So we are going for standard deviation, STD. So we are having the value of 36.9. Yes, that somewhat represents the dispersion in this data. I can say like the data is spread with 36.9 as a value. Hey guys, thanks for watching the video. In the next video we'll be discussing about some basic data visualization techniques in Python. So until then, see you, have a great day.